Okay, so Bacho, we are going to start our new chapter, which is amines. So what are amines? We are going to officially start this, right? So actually, I think you all are well aware about the word ammonia. You all are aware about ammonia. What is ammonia? Bacho, ammonia is like this. When an bonded with three different hydrogens and this and have one lone pair of electrons as well. So this is what, bacho, ammonia, right? We all talk about this in O levels, in AS, and then now A2. We are very familiar with this one, ammonia, right? You just need to keep remember whenever one H or more than one H, whenever one H or more than one H from ammonia is going to replaced by alkyl group, it would be known as amines. All right, keep remember this. Whenever one or more than one H from ammonia is going to replace by alkyl group, one or more than one or more than one H from ammonia when replaced by alkyl group, when replaced by alkyl group, right? What is alkyl group, bacho? You just need to keep remember alkyl group is actually whenever you talk about carbon chains. For suppose if you're talking about CH3, this is alkyl group. If you're talking about CH2, CH3, this is alkyl group. And even if you talk about like this one, so this is also alkyl group because this is also the number of carbons over there, right? So all these are alkyl groups. So whenever one or more than one hydrogen are going to be replaced by these alkyl chains, then ammonia is going to be converted into amines. All right, every one of you?
Yes, sir.
So for suppose what I'm trying to say, I'm just trying to say that for suppose this H or any one of them is going to replace by CH3. So for suppose this H is on there, this H on is there, and I just replace this H by CH3. Just look at over there. What is this? This is now CH3 and H2. And this is known as methyl amine. This is known as methyl amine, right? For suppose, I'm not going to do this. I'm just going to do this thing. For suppose I'm just replacing two hydrogens by two CH3s. Now this is what? This is CH3 NH CH3. Now what is this? Bacho? This is now dimethyl amine. This is now dimethyl amine, right? For suppose I'm just going to replace all the H's by CH3 like this, right? So what is this? Now this is trimethyl amine. This will be trimethyl amine. And for suppose I'm just going to replace any one of the H by benzene ring like this. So what is this? Now this is known as phenylamine, which is one of the very important part of our organic chemistry of A2. This is phenylamine. You can see this, that all of them, when one H is replaced by CH3, when two H's are replaced by two CH3, and when three H's are replaced by three CH3, and when one of them is replaced by benzene ring. So all these are known as what? They all are amines. They all are amines. Is that clear, every one of you?
Yes, sir.
So if you want to know that what is amine, so you just need to keep remember to being an amine, it's very essential that there should be three bonds, right? Three bonds. There should be three bonds and one lone pair must, right? There's exception of ammonia. You just need to keep remember there should be one of one of the alkyl chain also will be there, right? Just need to keep remember, if you have N, it's must that this N should have what? Lone pair, and this N should have 3 bond as well. This N should have 3 bond pairs and 1 lone pair as well, and there should be one, at least one alkyl chain out of 3 bonds. Then this will be what? This will be amine, right बच्चों? This is the important part of amines. 3 बॉन्ड होने चाहिए, एक लोन पेयर होना चाहिए, और उन 3 बॉन्ड में से एटलीस्ट एक बॉन्ड अल्काइल के साथ होना चाहिए, right every one of you?
Yes, sir.
Any problem in all of these things?
सर ये फिनाइल अमाइन का नाम कैसे आया, मतलब कुछ?
बेटे जब ये बेंजीन रिंग अटैच होता है ना, तो we need to name like this, phenyl, right?
Okay.
This is phenylamine. You can say that this is C6H5NH2. जैसे हमने phenol बोला था ना, same as it is, right? So let's move on. Let's talk about some primary, secondary, and tertiary amines. Let's talk about primary amines as we talk about in AS, like primary carbocations, secondary carbocations, tertiary carbocations, like we talk about primary, secondary, tertiary halogenoalkanes, like we talk about primary, secondary, tertiary alcohols in AS. So all these we need to talk about over here, primary, secondary, and tertiary amines, right? That was the same thing in alcohols and in halogenoalkanes and in carbocations that we are going to talk about in amines, right? So if you remember over there, whenever you talk about primary, there should be 2 hydrogens. There should be 2 hydrogens. So whenever like this, for suppose you have a nitrogen, and on this nitrogen we have at least 2 hydrogens. Whenever you have 2 hydrogens and 1 alkyl chain, this will be known as primary, right? Keep remember this, 2 hydrogens and 1 carbon chain. This will help you out to find out the primary amine, right? So this name is, this is actually CH3, CH2, NH2. So you can even say that कि जिसमें NH2 होगा, it will be primary amine, right? So NH2 will help you out that it will be primary. So I am just writing over here, N का bond होगा, इसके साथ कुछ और attach कर सकते हैं आप, methyl, ethyl, phenyl, whatever you want to add, it will be primary, right? And it is, this is the example over here, ethylamine. You have ethylamine, right? This is ethylamine. You just need to keep remember, 1 bond of nitrogen should be with a carbon chain, right? And the 2 of them are with hydrogen. If you find such amines, it will be known as primary amine. So in this way, it is also primary. If I just consider primary as 1 degree, so this is primary, right? This is also primary, right? Every one of you?
Yes, sir.
Then if you talk about secondary, so the secondary one is always when you have nitrogen and 2 of them are going to be connected with like carbon chains, right? 2 of them are like carbon chains like this, right? And 1 of them is going to be attached with hydrogen, when the hydrogen is going to be decreased, right? Lone pair is must. So जब एक कार्बन चेन और 2 हाइड्रोजन थे तो प्राइमरी, अब 2 कार्बन चेन्स और 1 हाइड्रोजन है तो it will be secondary. So you will find this thing must in secondary, which is actually nitrogen and hydrogen. तो 1 हाइड्रोजन होगा तो secondary, 2 हाइड्रोजन होंगे तो it will be primary, और जब एक भी ना हो हाइड्रोजन तो it will be tertiary. So if in easy words you can even say that कि आपके पास क्या होगा, आपके पास बॉन्ड में N और H होगा खाली अकेला, ठीक है ना? N और H होगा, बाकी इसके साथ दूसरी चीज अटैच हो सकती है. सो इट कैन बी राइट लाइक दिस. देखें आप, जो नाइट्रोजन है और हाइड्रोजन है, इसके साथ क्या अटैच है? 2 एक जैसे ब्रांचेस ना. सो आई कैन राइट इट CH2 ब्रैकेट में 2. So what is this? This is actually diethyl amine. This is diethyl amine. So whenever a nitrogen is connected with two carbon chain and one hydrogen, so it will be secondary amine. And you can even say that this one is also secondary amine, right? Because nitrogen is attached with only one hydrogen directly, and the other two bonds are with carbon chains. So this will be secondary amine, right? And if you talk about tertiary amine, tertiary amine is when the nitrogen is directly connected with three different carbon chains and there will be no single hydrogen attached with nitrogen. So if you have three different bonds and all three bonds are with a different like carbon chain, so it will be different or same. So it will be tertiary, like CH3 CH2. जरूरी नहीं है कि ये सारे ही एक जैसे अलग अलग हो सकते हैं. When you can write CH3 over here, but I'm just writing all same, so it will be easier for me to make condensed formula and to write the names. That's why I'm doing this. So it will be like that. You have nitrogen directly, right, with three different alkyl chains. So I can write R dash like this. Now it can be R, and this should be two, right? R, and it should be single. So what is the name? What is the condensed formula of this? It is N, right? And is connected with three similar branches or three similar branches like this. And the name of this is triethyl amine, right? And one more example is shown in here, just tertiary amines, right? If you want more examples of this, so I can even draw like this. That for example, I have a benzene ring like this, and over here we attach two hydrogens along with this nitrogen. So you can see this, that this is phenylamine. I already showed over there. So I'm just going to change it a little bit. So I'm just writing CH3 over here. So the name will be changed. What's the name of this compound? This will be the first carbon because the main functional group is on this. This is 1, 2, 3, 4th carbon. So the name of this compound should be 4-methyl phenylamine. And this is what? Primary amine, because the nitrogen over here is attached to two individual hydrogens, right? So this is primary amine. Same as it is, even I can draw this one as well. This can also be primary amine. For suppose if I just draw like this, a structure like this, a cyclohexane. This is a cyclohexane, and if I attach with nitrogen, and this nitrogen is attached with two different hydrogens, so this will be what? This will be cyclohexylamine. This will be cyclohexylamine, right? Now we cannot write phenylamine because it's a benzene ring nahi hai. ठीक है? This is hexylamine क्योंकि इसमें 6 carbon है, right? Then if you talk about the secondary one, so you can say that there should be N, or which is directly connected with only single hydrogen one time, right? And the rest of two bonds should be with the carbon chains, right? So these two bonds should be with carbon chains, and I'm just going to connect both of them with benzene ring like this, right? So what is this? This is actually you can say that this is diphenylamine because we have two benzene rings over there. So this will be diphenylamine, right? And for suppose if I just draw like this structure, you can see this in this structure also nitrogen is only connected with a single individual hydrogen. So you can call this the market name of this is piperidine, right? This is not in our syllabus to remember the name of this. I'm just going to show you one of the common compound in having a secondary amine over there, and the name of this compound, the market name of this is piperidine. You don't need to remember this. I am just giving you some examples of this, so it will be easier to understand what is primary, what is secondary, and what is tertiary, right? And same as it is, if I just draw like this over here, a nitrogen with a benzene ring, even you can draw 3 benzene rings around this nitrogen. So it will be triphenylamine, right? But I am not drawing this. I'm just drawing one phenyl, and I'm just drawing 2 CH3s. So the name will be different. All right, what should be the name of this? It will be dimethyl. This should be dimethyl, right? And phenylamine. This will be dimethyl and phenylamine. And you need to mention over there that all the methyls are on N. So you can say that N comma N dimethyl phenylamine, यानी कि दोनों के दोनों methyl nitrogen पर ही लगे हुए हैं. And same as it is very common compound that we talk about this in many of the time we talk about this. This is the structure of that. Just like this. For suppose the structure of this is a nitrogen having 2 bonds, and like this 3 bonds, and this is like this is one of the very common structure. And you can see this, the nitrogen in the second one is connected with 3 different carbons. So this is tertiary, the one which is over here. We are not talking about the first one because उसके अंदर double bond है, तो हम इस वाले की बात करें जिसको मैंने double किया. This one, this is tertiary nitrogen, and this is very common thing. ये जो structure है ये किस चीज का है? This is the structure of nicotine, which is present in cigarettes, right? Nicotine, right? So over here you can see this, but that I just show you that the few different things of you can see that primary, secondary, and tertiary amines, different structures. You can draw all these structures. I think it will be easier for you to understand what is primary, what is secondary, and what is tertiary. Right, every one of you?
Yes, sir.
Everyone, is that clear to all of you?
Yes, sir.
Any problem, anything that you want to ask? Any one of you?
सर ये NN डाइमिथाइल फिनाइलामाइन में नाइट्रोजन 2 दफा क्यों आया है? नाइट्रोजन तो एक
हाँ, नाइट्रोजन ने वहां पर शो किया है कि नाइट्रोजन जो है उसी नाइट्रोजन पे दोनों मिथाइल लगे हुए हैं. सो यू नीड टू शो द प्लेसमेंट ऑफ बोथ द मिथाइल ना. आपको एक जैसे 2 मिथाइल है ना, तो आपको दोनों मिथाइल की प्लेसमेंट बताना जरूरी है कि दोनों ही एन पे हैं. ठीक है?
ओके सर.
Yes, every one of you. All clear, everyone? Hamza, yes, Rabel, all clear, bete?
Yes, sir.
Okay, chale. Let's move on, man. Let's talk about some different thing of this chapter, which is very important for past paper questions. So we are going to start with the chemical properties. Chemical properties. Chemical properties of amines, right? Before we are going towards amines, we need to talk about ammonia, right? If you remember, or if you don't remember, that's okay. For suppose NH3, if you talk about NH3, I think you all are aware about this. When you add NH3 into the water, you will see that NH3 is going to make a dative covalent bond with hydrogen, and in this way ammonium ion is going to be formed and hydroxide ion is going to be formed. And this is actually reversible part. So I'm just going to show the reversible part as well, right? I think you all know that, right or not?
Yes, sir.
This equation is showing you that ammonia is basic in nature. This equation is showing you that the formation of hydroxide, that ammonia is actually basic in nature. This is alkaline, right, bacho?
Yes, sir.
But for suppose we are not believing this, so we want that there should be some verification as well that this is basic. We are not believing on this equation. We want verification for this. So let's see, if we talk about NH3 and we are reacting NH3 with HCl. If we are reacting NH3 with HCl, so we will see this, that NH4 positive ions and Cl negative ions are formed. And these ions are clearly showing you that over here, HCl loses H positive ion. So you can say that HCl donates its proton, donate H positive ion, while NH3 is going to receive proton, right? It's going to receive proton. So according to Bronsted-Lowry theory, you can even explain this again, so that if you talk about Bronsted-Lowry theory, according to Bronsted-Lowry theory, ammonia is actually base. Ammonia is actually base. You can say that acceptors of protons, acceptors of H positive ion, or you can say that protons are actually bases, right? Are bases. So this is now confirmed that ammonia is actually basic in nature, right?
Yes, sir.
Yes, but or not?
Yes.
If still if you are not believing this, that ammonia is basic, so what you can do, you can you can just put a damn litmus paper into the ammonia gas jar. So you will see that damn red litmus paper going to be changed its color from red to blue. So then you are going to be confirming this, that ammonia is basic in nature. So ammonia is alkaline gas. Now it's confirmed that ammonia is alkaline gas, right, bacho, or not?
Yes.
Yes, sir.
Okay, so this is for ammonia. We talk about this. Let's talk about amines. For suppose we have what we have. We are going to discuss about amines now. So for suppose I have CH3, CH2, NH2. This is what amine. If ammonia is basic, so what is amine? Amine acidic hai, basic hai, kya hai? Let's see. So for suppose if you talk about amine, so if you are going to react it with HCl, so you will see this, that CH3, CH2, NH3 will also form, and chloride will be like this. You will see that ammonia, like ammonia was having what? Hydrogen ion from HCl. Ammonia a proton receive kar raha tha. Same as it is, amine are going to be receive proton as well. So they are also proton acceptors. So in this way, amine is also alkaline in nature. So you need to say that lone pair on nitrogen actually responsible to accept hydrogen ions. So that is why amine can also act as a base, right? So keep remember this, that the lone pair on nitrogen, you will find over there, the lone pair on nitrogen is actually accepting proton from hydrogen ions, right? Right, it is actually accepting protons of hydrogen ions or from acids, right? Actually accept hydrogen ion from acids, right? This is what proton, right, bacho? That is why can act as a base. So amine can act as a base, right, bacho?
Yes. Yes, sir.
और ऐसा सब कुछ क्यों होता है? ऐसा इसलिए होता है because lone pair is going to form a dative bond with hydrogen ions. You can see over here like this. For suppose if we talk about ammonia, so what happened with ammonia? Ammonia is like this. This is ammonia, right? If you are having hydrogen ion over there, so you can see this, when ammonia see this, that hydrogen ion has a deficiency of electrons. So what happened with this nitrogen with its lone pair attack on hydrogen and provide these electrons to hydrogen and form what? Dative covalent bond. And we know that dative covalent bond is actually the one-sided sharing of electron. So both the electrons are shared from nitrogen over here, and in this way this ion will be formed, which is known as ammonium ion. The charge of hydrogen will move towards ammonium ion, right, Vicho?
Yes, sir.
And the same as it is will be going to have over here as well. For suppose if you have any any amine like this. For suppose we have this one of the amine like this, I'm just writing R over here. You can put CH3, CH2, CH3, whatever you want to put, you can put over here. I'm just writing R, right? So I'm just writing in general. So you can see this, that over here, once nitrogen see that hydrogen is a deficient of electron, so nitrogen can donate its lone pair to hydrogen and can form a dative bond with this hydrogen. So in this way, you can see this, it's quite simple that nitrogen, once nitrogen have a lone pair of electron, in any condition, nitrogen can provide that lone pair to hydrogen and form what? Positive ion, or you can say that in this way they can gain proton, right? So they can work as a base, right? If you want to draw it in the form of like this, it is nitrogen. You need to keep remember nitrogen, and over here it is hydrogen, it is hydrogen, it is hydrogen, and it is hydrogen. You need to keep remember that over here this is a covalent bond. So one electron from oxygen and one electron from hydrogen and one electron from nitrogen. And over here, one electron from hydrogen, one electron from nitrogen, one electron from hydrogen, and one electron from nitrogen. So dot and cross showing that each of the electrons are different, right? But over here, this is dative covalent bonds. You need to show both the electrons are from nitrogen. So they are same in the shape. So you can say that this is a dative covalent bond. You need to keep remember when the electrons are same, this is dative covalent bond. They can even ask you, what is this? So you can say that this is dative covalent bond. This is dative. And what is this? This is covalent. Right, every one of you?
Yes, sir.
So this is a thing that you need to keep remember. I think you all need time to write all these things. So just write all these things in your copy quickly, and then we will talk about the rest of the things after this. Okay, so Bacho, I think you all are well aware about this. You can see this, that once I show you over here, okay, if you have ammonia, so ammonia can work like this, that the lone pair on the nitrogen can be donated to hydrogen ion, and in this way the hydrogen atom is going to be covalent bonded or dative bonded with the nitrogen, and the charge of that hydrogen will be on the top of the whole molecule, right? And the same as if we have one of the hydrogen is replaced by any carbon chain like a CH3 or whatever you want to write over there, just write, for suppose I just write CH3 over there, na? So it will be methyl amine, and then you will see that there should be methyl as well, na? So this is again, if you have methylamine and the lone pair is also there on the nitrogen, so this nitrogen can also donate the lone pair to the hydrogen ion and form dative covalent bond with that, and the charge of the ion will be on the top of the whole ion, right? Or the whole the molecular ion, right? Now I just want that, Bacho, you will show this working for dimethylamine. You just need to show the working like this, the donation of lone pair of electron with the dimethylamine and also with phenylamine. Can you please draw this and send me the picture so I can check you are doing it right or not? The same working, the attacking of nitrogen lone pair on hydrogen ion and then the formation of dative covalent bond. Just do this, just draw this for dimethylamine and phenylamine, and then we will talk about some relative basicity or alkalinity of these molecules, right? Just okay, so you all draw it correctly, बच्चों. बिल्कुल इसी तरह आप लोगों ने बनाना था और आपने सबने ऐसे बनाया. Very good, every one of you. If you have one carbon chain, or if you have two carbon chain, or if you have a phenyl attached over there with a benzene ring attached over there, that all the main thing is that nitrogen has a lone pair, and then this lone pair can attack on hydrogen ion, and this dative bond form, and the molecular ion will be formed like this. Perfect, every one of you. The thing that we need to discuss is this, that actually primary, secondary, and tertiary, all amines are bases, right? All are bases. If you have primary amines, if you have secondary amines, or if you have tertiary amines, they all are basic in nature. They all are basic in nature, right? Why they are basic? Because we know that they have just lone pair, so they can receive hydrogen ions. So they are acceptor of protons. So they are basic in nature. but the relative basicity of these substances are different, right? So you need to keep remember that even phenylamine is also basic, right? Even phenylamine is also basic. phenylamine भी आपके पास क्या है बच्चों, बेसिक है, बट द थिंग इज किसकी बेसिसिटी ज्यादा है, किसकी बेसिसिटी कम है, we need to discuss this one over here. So let's see. If we talk about primary, secondary, and tertiary, I told you that all amines are what, basic, and I told you as well that phenylamine is also basic in nature, but there may be a difference in their strengths, right? There may be a difference in their strength. The one can be more basic and the one can be less basic as well, right? So if you talk about nitrogen, so as long as nitrogen has a lone pair, so it can accept a hydrogen ion, right? So that is why all the compounds in which nitrogen has a lone pair, it can work as a base, right? But I told you that the strength of their basicity can be changed, right? And it's all depend on the position of equilibrium, right? The position of equilibrium, right? So they all are like ये भी reversible reaction है, ये भी reversible reaction है, ये भी reversible reaction. They all are reversible reaction. So all their basicity, their strength, or whatever you want to ask, this all depend on what, the position of the equilibrium, right? If the position of equilibrium is well on right, so the strength will be different, and the position of the equilibrium is in the center, so the difference is the capability of having a proton is different, and it is on left hand side, so it will be different. So let's see which one is going to be more basic, right? So you need to keep remember that if the equilibrium lies on the right hand side, that means the substance is going to be strongly basic, right? Because you can see this is something in which the hydrogen is going to be gained, hydrogen ion is going to be gained. So once the proton can be easily gained, or it's well towards right hand side, so it's showing you that the gaining of proton is easier, and this is perfectly good. So when the property of having H positive ions is good, then the substance is well basic, right? And if the equilibrium is well on left, so you can say that कि यार अगर left पे है, then the capability to receive hydrogen ions is not stronger. If the capability of receiving hydrogen ions is not good, so that means it is not a good base as well. So it will be less basic. So keep remember this. If the equilibrium is on right hand side, so it will be good base, and if it is on left hand side, so it will be weak base or not a good base. Or if it is in the center, so that means it is the part of both right and left, so it will be in the center, right bacho?
Sir, can you repeat this again?
Yes, we will do this in a different way. Let's see. For suppose we have one of the substance with a lone pair over here, right? And when this will attack on hydrogen ion, this will form what? This will form a dative bond like this, right? Right?
Yes,
right,
sir.
Vishnu? You just look at over there. For suppose this equilibrium is not in the center, but this is lies on the right hand side, right? If the equilibrium is showing the position on right hand side, this means that the forward reaction is going to be favor, and the forward reaction is what? Showing you the gain of hydrogen ion, right? The gain of हाइड्रोजन आयन. इसका मतलब क्या हुआ? अगर फॉरवर्ड रिएक्शन फेवर हो रहा है, इसका मतलब हाइड्रोजन आयन गेन हो रहा है. हाइड्रोजन आयन गेन हो रहा है, इसका मतलब ये है कि आपके पास ये जो सब्सटेंस है ये बेस है, बिकॉज एक्सेप्टर ऑफ हाइड्रोजन आयन है ना, एक्सेप्टर ऑफ प्रोटॉन है. ऐसी है.
यस सर.
सेम एज इट इज. अगर ये लेफ्ट पर होता, तो ये आपको बताता कि यार वो हाइड्रोजन आयन गेन तो कर रहा है, प्रोटॉन एक्सेप्ट तो कर रहा है बट बहुत अच्छी क्वालिटी में नहीं कर रहा है, एक आध दो कर रहा है, एक आध दो कर रहा है, कम कर रहा है। तो इट सेज दैट ये बेस तो है बट वीक बेस है। ठीक है,
Yes, sir.
ठीक है। एंड सेम एज इट इज इफ यू वांट टू ड्रॉ इट फॉर वाटर, सो यू कैन इवन ड्रॉ इट लाइक दिस, कि आपके पास कोई सब्सटेंस है जिसके पास लोन पेयर है, एंड इफ यू आर रिएक्टिंग इट विद वाटर, सो क्या हो रहा है कि ये जो वाटर के अंदर हाइड्रोजन आइन है उसके साथ क्या बना रहा है, डेटिव कोवेलेंट बॉन्ड बना रहा है, और साथ साथ क्या रिलीज कर रहा है, हाइड्रोक्साइड आयन रिलीज कर रहा है। ठीक है ना, अगर ये वहां पर यहाँ पर ज्यादा हो रहा है, ये रिएक्शन फॉरवर्ड ज्यादा है, तो इसका मतलब है ये ज्यादा अच्छा बेस है, और अगर ये रिएक्शन बैकवर्ड ज्यादा हो रहा है तो इसका मतलब ये बेस तो है बट अच्छा नहीं है, बस सही है, नॉर्मल है, बेकार है। ठीक है,
Yes,
ठीक है
sir.
बस। तो एक्चुअली व्हाट आई एम जस्ट गोइंग टू शो यू ओवर हियर कि हमें ये एक्चुअली काम करना है किसके लिए, हमें ये काम करना है अमोनिया के लिए। अमोनिया के पास लोन पेयर होता है, जब अमोनिया पानी के साथ रिएक्शन करता है तो क्या बनाता है, अमोनिया बनाता है आपके पास NH4 पॉजिटिव along with hydroxide ion, and this is actually the reversible reaction, and same as it is CH3 CH2 NH2, this is what this is ethylamine, and when it is going to react with water, this is also what, reversible reaction, and in this reaction we will have what, CH3 CH2 NH3 positive and also hydroxide ion, तो ये भी बेसिक है, ये भी बेसिक है, ठीक है ना। एंड इफ यू टॉक अबाउट फिनाइलामाइन, सो फिनाइलामाइन क्या करता है, दिस इज phenylamine, right? So when you are going to react it with water, so this is also reversible reaction. You will see this, that phenylamine also gain what, hydrogen, and to form NH3 positive along with hydroxide ion. So these all are going to show you this pattern, that they all are producing hydroxide ions. It means they all are basic, right? But we need to discuss that which one is good base or which one is weak base, right?
Yes, sir.
So actually, if you want to know that which one is a stronger base or which one is a weaker base, so you need to see that which one having a better power to lose its lone pair or to gain a proton, right? So you can say that the power of base is how easily it donates its lone pair, right? This is what we are going to find out, the power, right? और जब वो डोनेट कर देता है तो फिर क्या बनाता है, डेटिव कोवेलेंट बॉन्ड बनाता है, डेटिव बॉन्ड बनाता है। सो दिस इज व्हाट this thing is going to show you the power of base. So I just want to know that which of these, that's ammonia है या ethylamine है या methylamine है या phenylamine है, इन तीनों में से ज्यादा बेसिक कौन सा है। We want to know this, कि इसकी पावर, किसकी पावर ज्यादा है, कि वो इलेक्ट्रॉन अपने जो इलेक्ट्रॉन है जल्दी से दे रहा है, तो किसकी पावर ज्यादा है, we need to know this. So for this, if you remember your AS, so I think you all know that alkyl groups are electron releasing effects, right? Alkyl groups are having, or you can say that alkyl groups have electron cloud, or you can say that they are electron releasing groups. Alkyl groups are electron releasing group. They are electron releasing group, right? You need to keep remember that अगर आपको याद हो अपना AS वाला, तो उसके अंदर आपके पास जो मेजर और माइनर प्रोडक्ट बनती थी, तो उससे आपको याद होगा, या उसके अलावा आपके पास अगर याद हो कि अपने SN1 और SN2 रिएक्शंस में इंडक्टिव इफेक्ट वाला सीन अगर आपको याद हो, तो वो सब क्या था कि अल्काइल ग्रुप्स जो होते हैं वो अपना इलेक्ट्रॉन क्लाउड प्रोवाइड करते हैं। जब वो अपना इलेक्ट्रॉन क्लाउड प्रोवाइड करते हैं तो उस हिसाब से फिर जो आपके पास पॉजिटिव आइंस होते हैं, ये जो कार्बोकैटाइंस होते हैं, वो क्या आपके पास जो है लेस अनस्टेबल या ज्यादा अनस्टेबल होते हैं। तो वो सारी चीजें अगर आपको याद हो इंडक्टिव इफेक्ट वाली, तो दिस इज द सेम थिंग। अल्काइल ग्रुप क्या होते हैं, इलेक्ट्रॉन रिलीजिंग ग्रुप्स होते हैं, वो इलेक्ट्रॉन प्रोवाइड करते हैं। ठीक है, जस्ट लुक एट ओवर देयर, ओवर हेयर इन दिस नाइट्रोजन के पास लोन पेयर है और ये हाइड्रोजन है, ये हाइड्रोजन, और साथ साथ क्या अटैच है इसके पास, CH2 और CH3, ठीक है ना। नाइट्रोजन के पास क्या है, यू कैन सी दिस दैट नाइट्रोजन के पास लोन पेयर है इथाइल अमाइन में। एक तो उसके पास लोन पेयर है, वो ऑलरेडी तैयार है इलेक्ट्रॉन देने के लिए, बट साथ साथ उसके पास एक इथाइल यानी अल्काइल अल्काइल ग्रुप भी लगा हुआ है और ये भी इसको इलेक्ट्रॉन प्रोवाइड कर रहा है ना। ये है इलेक्ट्रॉन रिलीजिंग इफेक्ट रखते हैं, तो ये भी नाइट्रोजन को इलेक्ट्रॉन दे रहा है। अब एक नाइट्रोजन पहले से इलेक्ट्रॉन देने के लिए तैयार है और पीछे से और इलेक्ट्रॉन इसके पास आ रहे हैं। नाउ it's easier for nitrogen to lose that electrons, right? Right?
Yes, sir.
So you can say that you can say that it is easier to lose electron for nitrogen in ethylamine if you are comparing it with nitrogen in ammonia, right? You can say that it is easier to lose electron pair for nitrogen in ethylamine as compared to ammonia, right? क्योंकि अमोनिया के अंदर कोई बकअप नहीं कर रहा पीछे से, सिर्फ इथाइलामाइन में बैक ऑफ द वर्क चल रहा है, वहां से इलेक्ट्रॉन आ रहे हैं, तो it is why it is more basic. That is why you can say that ethylamine is more basic than ammonia, right बच्चों?
Yes, sir.
And one more thing, if you talk about phenylamine, so phenylamine is like this, that we have a benzene ring and we have delocalized pi bonds inside, and this carbon is actually attached with nitrogen and this nitrogen is attached with hydrogen, and we have a lone pair of nitrogen, so it will be like this. There is a bond over there, right? Oh, sorry, bond with lone pair over there, right? So this lone pair is going to be delocalized in phenylamine, क्योंकि उसके पास तो इलेक्ट्रॉन्स की कमी है, तो ये जो इलेक्ट्रॉन्स हैं ये बेंजीन रिंग खींचने में लगा हुआ है। जब बेंजीन रिंग के पास ये इलेक्ट्रॉन जा रहे हैं तो ये इलेक्ट्रॉन किसी और को देने के लिए मुश्किल हो जाएगा, ठीक है ना। ये इलेक्ट्रॉन किसी और को देना क्या हो जाएगा, मुश्किल हो जाएगा, ठीक है ना। That is why it's difficult in phenylamine to lose electrons, right बच्चों? So you can say that lone pair of nitrogen is delocalized in benzene, is delocalized in benzene ring. That is why it is difficult for the nitrogen to lose electrons. So you can say that it is difficult to lose electron pair for nitrogen in phenylamine as compared to ammonia, right? As compared to ammonia, right? In this ammonia, ये सेंटर में, मतलब ये प्रोवाइड कर रहा है, कोई रोक नहीं रहा है इसको और ना ही कोई ले रहा है ना ही कोई इसको दे रहा है, तो ये बीच का है, ठीक है ना। So you can say that ammonia is now more basic and this is less basic. So if you are going to draw, you are going to make a ascending order of their basicity. So you can say that the most basic is ethylamine, then we have ammonia, and then we have phenylamine. Right, बच्चों? This is the most basic, and this is the least basic. Right, every one of you?
Yes, sir.
And this is a very important part of exams. You need to know this relativity or relative basicity in this chapter.